Megacasting is a revolutionary production method in the automotive industry, but it is also a complicated process to manage effectively when it comes to quality control. We have been developing a vision system for megacasting inspection that leverages cutting-edge vision technology across 2D, 3D, AI, and robotics. Megacasting enables a more efficient and sustainable production of electric cars, but the large cast aluminum parts are challenging to inspect for quality due to a combination of factors. The part is very large. If you could unfold it, it would be up to 10 square meters. At the same time, the surface defects are minimal, but they are critical as they may cause the structural elements of the car to break down. The geometry is complex with deep pockets, and the surface is glossy with a lot of variation from expected residues. Finally, the full inspection cycle must be completed in just 1 minute. In other words, it is the perfect storm when it comes to visual inspection, and it will take manual inspectors a very long time to do. So let's look at how we approached it when we developed a vision system that could solve the task. Several specialists were put to work. We had our simulation experts produce artificial images for testing by creating synthetic models of the megacasting and virtually experimenting with lighting and camera setups. The 2D experts developed complex sensor heads with up to 9 cameras to identify potential problem areas on the part. Our 3D experts identified and tested possible sensor types we could use, as we needed a complete overview of each sensor's true measurement accuracy. Finally, we developed models to predict how long it would take to cover the large item with this many edges and corners. With this, we could determine how many sensors we would need. This test system shows the principle of the megacasting system on a smaller scale. So imagine that this cast was a lot bigger and we had 5 robot arms scanning it to cover the surface from every angle. In general, the vision system works as follows. First, the casting is scanned with up to 5 robot arms, each of which carries up to 9 cameras and light sources. This all-seeing eye enables us to cover all the important angles of the megacasting in the shortest period possible. The purpose of this first step is to detect potential defects, which is done with AI. We use 2D as a first line of defense, you could say, since it wouldn't be possible to 3D scan the entire part in the 1 minute we have for the entire process. Afterwards, the candidates identified in step 1 are now scanned with 3D sensors, both laser line scan and area scan, so that we can classify defects, again using advanced AI models. By using the 3D sensors for dimensional measurements as well, we can perform this inspection during the same session as the surface inspection. This way, we can add dimensional measurement early in the production process instead of waiting for the more time-consuming inspection with a 3D measuring machine at the end of the production line. This saves a lot of resources and makes the reuse of the aluminium much easier, which again adds to a more sustainable production process. So, by combining multiple cutting-edge technologies and running several specialized inspection processes simultaneously, we were able to create a vision system that can inspect a megacast for surface defects and dimensional deviations in 1 minute with high accuracy.